Welcome to aminacademy.com. In fluid mechanics, let us discuss about flow through fully and partially submerged orifice. Fully submerged orifice is one which has its whole of its outlet side submerged under liquid. That means outlet of this orifice is submerged in the liquid in section 2. Same kind. It is also called a totally drowned orifice. Figure shows a fully submerged orifice. Consider 2 points 1 and 2. Point 1 being in the reservoir. This is a reservoir, and on the upstream side and orifice is at point 2 being the vena contracta. This point is vena contracta as shown in the figure. Now let us consider the given things first. H1, height of water above height of water above the bottom of the orifice. Here H1, this above the bottom of the orifice, above the bottom of orifice, above the top of the orifice, not bottom, above the top of the orifice. H2, H2 is height of water above the bottom of the orifice, from bottom of the orifice up to this level. Height of water above the bottom of the orifice, above the H equal difference in water level. This H is difference in water level in the first reservoir and second one. H we got it. Now B, width of the orifice. CD, coefficient of discharge. Now height of water above the center of orifice on upstream. In section 1 you are talking about. Height of water at section 1 equal H1 plus H2 minus H1 by 2, which is equal H1 plus H2 by 2. Then height at section 2 Here, height of water at section 2 is H1 plus H2 by 2 minus H, because this level is H now. Now, applying Bernoulli's equation at sections 1 and 2 equal, that is P1 by rho g plus V1 squared by 2g equal P2 by rho g plus V2 squared by rho g. Now, P1 by rho g is equal, head is, at section head is what, H1 plus H2 by 2 and P2 by rho g is H1 plus H2 by 2 minus H, and V1 is negligible. Here, your velocity of water at section 1 is negligible. Therefore, we can write the equation as H1 plus H2 by 2 plus 0, because V1 is negligible. So V squared by 2g is negligible. Then next equal H1 plus H2 by 2 minus H plus V2 squared by 2g. Therefore, here this terms cut both sides. Therefore, we can write H equal V2 squared by 2g, which gives V2 equal square root of 2g H. Therefore, here we found the velocity at vena contracta is square root of 2g this H. H means here above the water level and in the first section, and above the water level in second section. So it is H. Now, next we'll give more space. Now, area of orifice is equal B into H2 minus H1. Therefore, discharge Q equal, discharge through orifice Q equal coefficient of discharge into area, that is B into H2 minus H1 into velocity is 2gh. This is a discharge through the orifice, fully submerged orifice. Now let us discuss about partially submerged orifice. Here, partially submerged orifice is one which has its outlet side partially submerged. This outlet is partially submerged. Let us partially submerged under liquid. It is also known as partially drowned orifice. Partially drowned orifice. Thus, the partially submerged orifice has two portions. Like before, the upper portion behaves an orifice discharging a free, while the lower portion behaves as a submerged orifice. Like in opposite manner, submerged orifice. Only a large orifice can behave as a partially submerged orifice. The total discharge Q through the partially submerged orifice is equal to the discharge through free and the submerged portions. Therefore, discharge through the submerged portion is given in equation. Therefore, simply you can write discharged through the submerged, because it's considered partially submerged orifice is considered fully submerged orifice by this section. That means here, from here to here, reservoir to it goes, but we are considering the partially submerged orifice as a fully submerged orifice if you are considering from this section to this section. Therefore, discharge through the orifice equal Q1 coefficient of discharge into B width into H2 minus H1. Here H2 minus H1 gives this H2 minus H1 gives this portion, this width of this. That means this height. And H2 minus H means middle pole. H2 minus H into velocity square root of 2g H. Therefore, you can write discharge Q1 equal CD B H2 minus H 2g H. Then Q1 is from now Q2 equal discharge through the free portion is discharge through free portion is by formula we are having Q2 equal 2 by 3 CD B into 2G H. You can write this one as H H2 H2 power 3 by 2 minus H2 minus 3 by 2 minus H1 power 3 by 2. Therefore, total discharge Q equal Q1 plus Q2. Then we have, therefore, Q equal CD B H2 minus H plus into square root of 2G H plus 2 by 3 CD B into square root of 2G and H 3 by 2 minus H2 3 by 2 minus H1 3 by 2. So this is the final value of the total discharge through partially submerged orifice. We have done. Please subscribe our YouTube channel.